In this video, we are going to do a practice problem to prep for quiz 1 in which we construct a set with a given property. So the example says, let U be the set that contains 1, 2, 3, 4, 5, 6, 7, and 8, and A be the set that contains 1, 2, 3, 4, 5, and 6. For each of the following, give an example if it is possible. If it's impossible, indicate that and justify why. So part A of this example says that A union with some set B needs to be U, the universal set, and A intersected with B should not be the empty set. So I want to begin by giving you the opportunity to try this question. Pause the video for 2 minutes. That's super important, like I mentioned in the last video, especially for quiz and exam practice in math courses, to pause and actually try the questions on your own. It's a good check to see how well you understand these concepts on your own. And if you get stuck, well, then you know to go back and review your lecture notes, the lecture videos, and then try extra practice problems that may be similar from the worksheets and from our optional homeworks. So 4, 3, 2, 1, pause that video. Pause it for 2 minutes to try this question on your own first. All right, so hopefully you've done that. Hopefully you've paused it for 2 minutes to try this. So let's look at each of these conditions. The first one says the union of A and B needs to be U. So for that to be possible, at the very least, B must have 7 and 8 in it, those two elements, because 7 and 8 are in the universal set, but they're not in A. So for us to have a hope of the union being all of U, B has to have at least 7 and 8 in it. Okay, now let's look at the other condition. The other condition is saying that the intersection of the two sets is not empty. So that means that B and A must have at least one common element. Because if they had no common elements, then their intersection would have been the empty set. There would have been nothing in the intersection. Okay, so is that possible or impossible? Well, it's possible. It's definitely possible. And in fact, there are many examples of this. So I'm going to give one. So one is, what if we let B, we got to make sure it has 7 and an 8 in it. So let's just put 7 and 8 in there. But it's got to have, based on the second condition, it's got to have something in common with A. At least one thing in common with A. So maybe I'll just put 1 in there, because I know A also has 1. But as long as I make it have something in common with A, we're going to be good. Okay, so in that case then, if we check the two conditions, then the union of A and B is definitely U, the universal set. And the intersection of A and B, well, what's common to A and B then? It's just the element 1, but that's good enough because we just needed the intersection to not be empty. So which is not empty. All right, and that's the idea for part A. So let's do one more part to this question. So B says the union of A, B, C, and D is U, and A, B, C, and D are pairwise disjoint and non-empty. So for this, pause it for another maybe 3 minutes for this question, and try it on your own first. 4, 3, 2, 1, pause the video. Pause it for 3 minutes and really try this on your own first. So for this, I'm going to focus on the pairwise disjoint condition, because that's a bit different from anything that it said in part A. So let's recall what this means. Whoops. What does pairwise disjoint mean? It means that when we draw the sets, there is no overlap between any two of the sets. So if I focus on this condition that says, oh, the four sets are pairwise disjoint. So if I draw a circle for A, and I know how many elements are in here, I know there are 6 elements in this. 1 through 6, those 6 integers. And then if I draw a circle for B, a circle for C, and a circle, whoops. So, a circle for C and a circle for D, there can't be any overlap between any two of the circles. That's what pairwise disjoint means. So the question also tells me that these 4 sets, A, B, C, and D, they need to be non-empty, which means each has at least one element in it. Okay, so A has 6 elements, and then B, C, and D individually have at least one. So for this to be possible, A, B, C, and D have at least, if we combine all their elements, I know A has 6, and then B, C, and D have to have at least one. So if I just do 1 plus 1 plus 1 plus 1 for B, C, and D, that's the least amount of elements that they could have collectively. So that adds up to 9. So 9 elements combined, I'm going to say. But that's impossible. This is impossible, since U, our universal set, only has 8 elements. And we've shown that if this were possible, that A, B, C, and D combined would need to have 9 elements. And there's no overlap between any of the circles, so it's not like we'd be counting any of these elements twice. And that makes this impossible. So in the next video, we will do an example with 3 overlapping sets.